coefficient and proved it by induction. And now we want to talk about the multinomial coefficient, which notationally looks like this. N choose N1, choose N2, and so forth up to N choose R. Okay, so this is the notation we're going to use. Let's talk about what it's going to mean. But first, let's, set it up for us. So if we want a set of indistinct objects divided into R distinct, it's not overlapping, R distinct groups of sizes, N1 for the first group, N2 for the second group, and so forth up to N sub R for the rth group, in such a way that if I add them all up, I get all of N. So it's like I'm taking this group of size N and I'm dividing it up into non-overlapping sets, N1, N2, N3, and so forth, so that all my elements are there and they don't belong to more than one group. Okay, so let's count all the ways I could do this. I could take this set of N and divide it into R distinct groups of different sizes. Well, this is really just a break it down into steps problems. So step 1 would be, of the full group, choose the group of size N sub 1. Then once we've done that, we got to remove that from the group. So let's say that was what we chose. So now of the N minus N1 elements, we're going to choose N2. That's for the next one. And then the next set, we've now taken that out as well. So of the N minus N1 minus N2, we choose N sub 3, and so forth, all the way down, which at the end, we should just have what's left here, and we choose all of them. Okay, so that's how we would take a group of size N and split them up into into these groups that are ordered in such a way, N1, N2, and so forth, up to NR. Now let's split it up and see what this actually is, right? So this is N factorial over N1 factorial, and then N minus N1 factorial. All right, this next one would be N minus N1 factorial over N2 factorial, N minus N1 minus N2 factorial. This next one would be N minus N1 minus N2 factorial over N3 factorial, and then N minus N1 minus N2 minus N3 factorial. I'm gonna run out of room, ... and just dot it up to the end. Okay, so notice what's happening here. That's canceling with that, that's canceling with that, this would cancel with that last one, and we'd be left with just the N factorial on the top. All these second pieces are canceled all the way through, and we're going to be left with N1 factorial, N2 factorial, all the way to N sub R factorial. So this is how we calculate the multinomial coefficient and denote it like this. Okay? So let's say we wanted to, now this does matter, this is accounting for the order of these groups. So we're doing them in these distinct groups where the first group is different than the second group, even if they're the same size. So let's say, for example, we want to take 10 people, let's say N is equal to 10, and we want to put in group A, they're going to clean the chalkboards. Spell that right. And that group is going to be size 2. And then in group B, they are going to sweep the floors. And that's also going to be of size 2. And then in group C, we are going to wash dishes because somehow in our classroom we have dishes. And that one is going to be size 6. Sorry, that's a 3. Even though these are the same size, group A is different than group B. So if you're put in group A, then that's different than if you're put in group B. So let's just write it out first without our new notation here. What we would, to start, we'd say, well, choose the ones that go into group A. And of the 10, we would choose 2. And then now of the 8 that aren't those 2, we're going to choose 2. And now the 6 that aren't those 4, we're going to choose the remaining 6. And what that actually becomes is 10 factorial over 2 factorial, 2 factorial, 6 factorial. Now here's where you have to be careful. Let's say we have 20 football players. And we want to pair them up to room at an away game. We want to pair them up in hotel rooms. Okay, so really it's tempting to go, okay, so of the 20, choose the first 2, then of the 18, choose the next 2, and then of the 16, choose the next 2, and so forth all the way down till we get to the last 2. The problem is, which would be, if we wrote that out, 20 factorial over 2 factorial, 2 factorial, we would do that 10 times, right? Because we have 10 pairs of 2. Now here, what's different about this problem than the one above is being in, if I put John and Bill in room 1, or if I put them in room 2, that's not a different pairing. So here we're looking at pairings, and those pairings, if I move them around but keep them glued together, I'm going to overcount them by that many. So I don't want to order these partitions. So I have to divide out all the ordering of these. So I'm going to divide it out by, how many pairs do I have? 10 factorial, because I don't want to overcount the permutations of these pairs.